Warm greetings, learner. Myself, Dr. S. Sendilrani, Associate Professor in Department of EEE of Velamal College of Engineering and Technology, will be presenting a topic transformer, its construction, types, working, and application. We'll start with the definition of transformer. As the name indicates, here the electrical power it is transferred from one end to another end, and this transformation will be found without change in frequency, and this is possible because of the process called electromagnetic induction. And here during this transformation process you can find either an increase or a decrease in the voltage, which is with a corresponding decrease or increase in the current. So to sum up this definition, a transformer is a static device which transfers electrical energy from one circuit to another circuit through a process of electromagnetic induction. The working principle of an electrical transformer is mutual inductance. So here the mutual inductance seen between two or more windings or coils allows for the electrical energy to be transferred between the circuit. So here the two coils are, one coil is called as primary, another coil it is called as secondary. Between the primary and secondary coil, a magnetic circuit will be created, and that magnetic circuit it allows the transfer of electrical energy from the primary end to the secondary end. And this is according to the Faraday's law of electromagnetic induction. So an EMF will be induced in the secondary end for the voltage that is applied in the primary end. And here you can find a current flow provided the secondary it is closed. Working principle, here as I mentioned earlier, to the primary winding an alternating electrical source have to be applied, and this alternating electrical source it creates an alternating current, and this alternating current it is the cause for the continual change in the alternating flux, and this flux surrounds the winding, and this winding it will have a linkage with respect to the secondary, and thus in the secondary end you are able to find an induced voltage. And this is how the flux linkage it will take place. There are two coils as I mentioned, a primary and the secondary. To the primary end an alternating source it is applied, and due to which a flux it is being generated, and this flux it is being linked with the secondary coil, and here you are able to tap an induced voltage. So here you can find that the primary and secondary they are not physically connected, they are physically separated. It means that they are electrically isolated, whereas this area it says that they are magnetically coupled. So even though they are physically separated, they are magnetically linked when an alternating source it is applied with respect to the primary end. And this is the schematic view of the transformer. In this picture it is a picture of a real transformer which we are using in our laboratory. In your EP lab you would have found this transformer you would have used for the experiment rectifier. Here the schematic view I have presented here, and this schematic view contains two windings. One winding we call as the primary winding, so this is the input side, and the other winding it is called as the secondary winding, which is called as the output side. So to the primary end we will be applying an alternating source, and with respect to this a current it flows here, and this causes a flux to be linked. So here within the core a flux it is being created, and this created flux it links the secondary winding. So due to this a current flows here, and you are able to tap an induced EMF here. So here again you can find that the primary winding and the secondary winding they are electrically separated, whereas they are magnetically coupled. You can find that this orange color winding or coil, they are not having direct connection, whereas they are connected by this blue color dotted marks. This blue color dotted marks, it is nothing but the magnetic flux. And here NP and NS are nothing but the number of turns that are wound with respect to the primary end and number of turns that are wound with respect to the secondary end. So this NP and NS, it decides the amount of voltage that can be found with respect to the secondary. So here these are the deciding factors of the transformation process that takes place in the electrical apparatus. And the flux that is generated within this core area, it is called as main flux or the magnetic flux. It is the useful flux which leads to the transformation of electrical power. And this flux on the other end of the coil, you can find that there are additional flux that are generated here, and these additional flux are referred as leakage flux. So to the primary end, you are applying an alternating source which creates a magnetic circuit, and this magnetic circuit, it becomes closed, and due to the closed circuit in nature, to the secondary end an EMF it is induced, and this EMF, it is the output voltage of the transformer. Here again the previous clippings schematic diagram I have redrawn here. You can find that two coils, primary and secondary coil, which is being wound over the core, and within the core you can find the main flux or the useful flux, and outside the cores a certain amount of flux it is being found, which is called as the leakage flux. So we are in need of this only, we are not in need of this leakage flux. The transformer can be divided into three important parts. One, it is called as primary winding, another one it is called as core, and this core, it is going to create the magnetic circuit, and hence we refer this as a magnetic core, and the third one, it is called as the secondary winding of the transformer. First we will start with the discussion on the primary winding. What happens in the primary winding? We'll be connecting an alternating source. This alternating source, it produces a magnetic flux which will be due to the electrical source that is connected to it. Okay, so due to the application of the alternating source, a current it will flow that creates a flux, and that flux it will be linked to the secondary. So this linking operation, it is carried out by the magnetic core of the transformer. So here the core, it will contain both the primary winding and secondary winding. The magnetic flux produced by the primary winding, it will flow through the low reluctance path, and due to this it gets linked with the secondary end, and when it is being linked with the secondary end, you will be able to tap the induced voltage. And here you can find that a closed magnetic path it is created. The circuit are electrically separated, whereas they are magnetically coupled. So the last part of the transformer, it is the secondary winding of a transformer. So the flux that is generated in the primary winding, which passes through the core, it will be linked with the secondary winding, where a desired output it can be generated. This desired output is called as the induced EMF of the transformer. So the three important parts of the transformer are the primary winding, magnetic core, and the secondary winding. Next we will pass on to the classification of a transformer. Transformer, it can be classified under three categories. One, it is called as based on phase, based on core, based on the cooling system. Based on phase, it is classified into two types. One, it is the single phase, the other one it is three phase. Based on the core, based on the construction also we can say, it is classified into two types. One, it is called as core type, the other one it is called as shell type. The third one, it is called as the classification based on the cooling system. So here the cooling system classification, it leads to self-cooled, air-cooled and oil-cooled. we will have the discussion first on the classification based on the construction. As I mentioned earlier, the construction classification, it has yielded two types of transformer. One, it is called as core type, the other one it is called as shell type. So here I have given the picture of core type and shell type of the transformer, and here in core type you can find that the core, it is holding the primary and secondary winding wound on the limb. So this region, it is called as the limb. And here the structure of the limb for both the cases are different. Here you can find an L-shaped structure, whereas here you can find the E and the L-shaped structure. So here it is both are L. This one it is L, this one it is another L, whereas here it is an E structure and this one is a L structure. So that's why we say that here an L type construction it is being formed, whereas here the limbs are constructed in the shape of E and L. We'll start a detailed discussion on core type transformer. In the previous figure, I have given a clear view. If we have two L-shaped structure which is joined together to form a core. So the primary and secondary, it will be wound over the respective limbs and they will be physically separated. So this is how the structure it will be. In case of single phase, it will be like this. In case of three phase, it will be like this. So three phases RYB, so that representation it is given as three phase. Here it is a single phase. You are having a primary end and you are having a secondary end. So here the primary coil and the secondary coil, when it is wound over the limb, insulation materials are used here. So here the insulation material that are commonly used are paper, cloth or mica. And here the low voltage winding are placed near to the core. And here the reason why we place this LV, that is low voltage winding, near to the core, it is easy to insulate. So for easy insulation only, the LV winding are placed near the core. So here an L-shaped structure, over this L-shaped structure to both the ends we will be winding the primary and secondary winding. This forms the core type transformer. Next we will get into the discussion of shell type transformer. Here the coil it is stacked. So here you can find that one above the other the arrangement it is formed. And as I mentioned that you will have the limb as an E-shaped and L-shaped structure which forms a rectangular shaped structure, and over this you will be winding the primary and secondary. So here over the central limb both primary and secondary windings are wound, and this is the representation for single phase and this is the representation for three phase. Whereas in previous case we had the L-shaped structure where primary and secondary windings were separately wound over the L-shaped structure and they were physically separated. Next we will have the comparison between this core type and shell type transformer. So based on the arrangement, when we classify, here we can say that in the core type the winding surrounds the core, whereas in shell type the core surrounds the winding. So here winding it is kept in the outermost region, whereas here winding it is kept inside the core. So that's why the classification it says that winding surrounds the core, whereas here core surrounds the winding. And here that lamination strip, that limb, it will be cut in form of L-shaped structure, and here it will be of E and L type. So based on the construction only, here the lamination shape it is also be decided. And here the winding can be called as concentric or cylindrical winding, whereas here since we are going to stack the winding, we call it to be sandwich or the disc winding. And here we have two limbs, whereas here we have three limbs. So that E-shaped structure only it creates the three limbs. Here you require more insulation, whereas here you require less insulation. And here the magnetic circuit created it is 2, whereas here the magnetic circuit is created it is 1. So here, as I mentioned that the coil, it is carried in the central limb, and either side the flux it is carried, it is half of the flux. So the entire flux it is carried in the E-shaped structure, and the E-shaped structure central limb, you can find that entire flux. There is here you can find the entire flux, and here these two, it will have the share the value of the pole flux. And the magnetic circuit created here, it is 2, whereas here it is 1. Next classification, it is based on the purpose. So here, based on the purpose, it is whether we need an increased voltage or a decreased voltage. So if you are in need of increased voltage, then you have to step up this transformation operation, and hence a transformer, it is called as step up transformer. So here the primary winding, it will have a low voltage, whereas the secondary winding, it will have a high voltage. Whereas in case of step down, if you are having a very high voltage, that high voltage, it can be stepped down or reduced to a low voltage. So here the primary end, it will have high voltage, secondary end, it will have a low voltage. Whereas here the primary end, it will have a low voltage, and here it will have a high voltage. So I shall repeat it. Step down, it is primary, it is high, secondary, it is low. Step up, primary, it is low, secondary, it is high. So that's why the word up and down. Step up, you are increasing, here you are decreasing. So the transformation, it gives either an increase in voltage or decrease in voltage depending upon the type of transformer that is employed. And basis of the supply, it can be classified as a single phase transformer, or it can be classified as a 3-phase transformer. And based on the pooling arrangement that are used in the transformer can be classified into oil-filled self-cooled type, oil-filled water-cooled type, air blast type, or it is otherwise called as air-cooled. So here oil at times you can find oil immersed transformer. The role of the oil, it is here during the transformation of the electrical power, more amount of heat will be generated. That heat, it will be absorbed by the oil. So here the oil, it acts as a coolant. Next we will start our discussion with the working. So here mutually induced EMF, it is the main concept behind the transformation action that is taking place in an electrical apparatus. This electrical apparatus, it is static in nature. The arrangement itself, it shows that here you don't have any moving part. One end you have a primary coil, the other end you have the secondary coil. Primary coil, it acts as the input, where an alternating source it is provided that generates a current of value I1, which will induce an EMF with respect to the primary, which is called as E1. And here a magnetic flux it is created. This magnetic flux, it forms a closed path, and the magnetic flux representation I have given as phi here. This phi, it links with the secondary, and due to that phi, you can find that there is a current flow in the secondary winding, provided the secondary end it is closed here. And this transformation, it is called as mutual induction, and hence the EMF induced due to the mutual induction, it is called as mutually induced EMF. The flux relation with the winding. As I mentioned earlier, there is no electrical connection between the two windings, whereas these two coils are connected magnetically. So here the electrical power transformation from primary end to secondary end, it is accompanied by a process called as mutual induction. The relation of d phi by dt, where this phi, it is nothing but the change in flux with respect to time. So this d phi by dt, along with the number of turns, it is going to decide the amount of flux that is to be presented in the primary and the secondary. So here we have an alternating flux. That alternating flux with respect to varying time period along with the number of turns, it is going to produce an EMF, and this EMF induced, it depends upon the number of turns that is provided with respect to primary and secondary. So the voltage, it is dependent on the number of turns that is wound in the secondary and primary end of the transformer, or you can say that the secondary and the primary coil of a transformer. So here the induced EMF, it is giving one concept. That concept says that the direction of induced EMF, it is opposite to the applied voltage. So here the applied voltage is in this direction. So to the primary end you are applying the voltage, and this applied voltage, it creates a closed path through this magnetic flux, and here a secondary voltage, it is being induced here, and here you can find that the direction it is being given. So this is the path of the applied voltage, whereas the path of the induced EMF, it is in this direction. So that's why we say that for the applied voltage, an opposing direction, it is being created by the induced EMF. EMF relation with the turns. So here EMF relation with the turns, it can be put into a simple statement. They are directly proportional. Depending upon the number of windings, here you can find the EMF induced with respect to primary and secondary, where E1 and E2 are the EMF induced with respect to primary and secondary, and N1 and N2 are the number of turns that are wound the primary end and the secondary end. So based on this only, we say that a step up or step down operation, it can be obtained. Finally, we'll get into the concluding part, the transformer construction. So this is how a transformer, it will be in a schematic view. So this is the real picture of a transformer. So here we are having the correlated images. So one, it is a conservatory tank. Here you can find that a tank like structure and overhead tank like structure, it is being found over the transformer. So this, it is nothing but the conservator, or it is called as oil tank. So this, it will have the oil that is to be filled inside the transformer. So the transformer, the entire region, it is being filled with the oil, and the role of oil here in the transformer, it is for cooling the heat that is being generated during the transformation process. So here a core type transformer representation I have given, where one end it is having a primary coil, the other end it is having the secondary coil, and this entire arrangement, it is being kept inside a concealed tank. So that's what you can find here. This one, it is a concealed tank, and this concealed tank, it holds the primary and secondary winding, and this core, this arrangement, it is placed inside an oil filled concealed tank. So this entire area, it is going to have the oil, which is going to act as a coolant, and the primary end and the secondary end are being taken out here. So the terminals are taken out, and it is being provided by proper bushing. So that representation you can find here. Here there is the bushing representation, and the terminal that is being taken out from the primary and secondary, it is represented here. And this one, it is called as the breather of the transformer. So the most important part of the transformer, I can say. So here the name breather, it says its role, it is like this. There is the oil level and the oil purity, or the moisture content that is present in the oil, it will be indicated by the structure called as breather. So here the breather, it will be filled with silica gel. By the change in the color of the silica gel, you can find the level of moisture content that is presented in the oil. So here the moisture content oil, when it is being poured inside this closed chamber, electrical short circuit may occur. So to avoid that, here what a breather arrangement it is being provided. This breather, it indicates what is the actual level of moisture content that is presented. So when there is the change in the color, this breather, it will say the level of oil that is to be removed or that is to be replaced in the inside the transformer. And here you can find that the conservator tank, it is being half filled. This region, it is found to be empty. The reason it is, here during the transformation action, heat it will be generated, and this heat, it evaporates the oil, and this it will be raised as the gas in the conservator tank. So you require some space here. So here the oil, it will be moved up and down inside the conservator tank. So to conclude, a transformer, it is a static electrical apparatus which is having two physically separated coil. One, it is called as a primary coil. The other one, it is called as a secondary coil. They are physically separated, whereas they are magnetically coupled. And based on the Faraday's law of electromagnetic induction, the transformation of electrical power from the primary end to the secondary end, it occurs. Based on the construction, the transformer, it can be classified as a core type or shell type. In both the cases, the electromagnetic induction, it is going to induce an EMF with respect to the secondary. You can find a current flow provided the secondary end, it is being closed. So depending upon the requirement, either you can increase the voltage or you can reduce the voltage, and this increase or reduction in the voltage, it can be decided by the number of turns that are provided with respect to the primary end and the secondary end. So here number of turns, it is one of the important parameters that decides the amount of transformation that is taking place inside the transformer. So that relation only here I have highlighted. E, it is directly proportional to N1, E2, it is directly proportional to N2. So here this directly proportional, it says that by increasing or decreasing the number of turns, naturally the EMF, it will be increased or decreased. And this is the constructional view of a transformer. And you can share your comments. Thank you.